quickly. So this is we are given with this exit age distribution as a rectangular distribution. So we are asked to get the conversion, which is a first order reaction. Okay. So for this, we need to get this E max, because this also needed to solve this. Or else we need to get the equation of this E over this range. So for that you can easily get by equating this to 1. So we know this base and height we can easily get. So okay, now E is available, and conversion relation is, or is concentration, average concentration divided by initial concentration is the concentration this in a batch reactor multiplied by E of T for the given reactor. So for the given kinetics, which is first order, so for the batch reactor we can get this. Okay, so we have this Ca by Ca naught. So we have this expression. So you can easily do this integration, not a difficulty. So you can get the average concentration. That is a question asked. Maybe to extend this, suppose you are asked to get the T mean. So T mean is simply there is a main residence time, simply the midpoint of this rectangular distribution. Okay, that you can also get this from this T into ET integral of this thing. That is a valid thing for T bar. You can also get this, and that is also coming to the same value as 4 minute. And sometimes this variance is also needed to say about this modeling non-ideality in terms of number of tanks in series. So for that, variance is this is T bar. So for variance, that is it is T square multiplied by T minus this T bar. Okay, T bar is available, and this and all you have to get it. So by that way we have this T bar. There is a variance of distribution, and number of tanks in series is equal to this T bar square by variance. Always in terms of number of tanks is inversely proportional to variance. Always sometimes they can also say this variance in terms of dimensional lifetime. Always tau square by T bar square. That is also called as the theta theta square. Always saying this variance in terms of dimensionless units. Always variance is having minute square. Always time square. So always the number of tanks in series is inversely proportional to variance. Okay, so now we are having this number of tanks in series coming to 48. That means you are having, this distribution is like a this plug flow case. For a ideal plug flow, we'll be having what is it? Impulse. Whereas we have a pulse. Of course, this is match getting coming to 48 number of tanks in series. This, if you have large number of CSTR in series, it is approaching a plug flow case. So it is also now coming. So a number of tanks in series is coming to 48 for this problem. And so we can also get the conversion for this reactor, whatever we have found. Okay, so the conversion we have found to be using this formula. You can also suppose you have simply calculated the conversion simply from this PFR case. Because now we are getting this number of tanks in series coming to 48. So for that, now the conversion will also be matching. Otherwise, the concentration is coming to 0.9. Previously, it was coming to 0.904. So in that way, you can simply get the conversion whenever you are given with this kind of rectangular distribution using a plug flow case. And uh, suppose you have tried to find the conversion using MFR formula, you will be getting totally a very different answer. Okay. Now, of course, this was a question in this recent thing. We were given with this E versus time. So for that, we were asked to get the mean residence time. Okay, simply you can take this what is it centroid values 0, 0, 0, 4 and 0.5, 0 that centroid is giving. You can also get this by this getting the equation for this, and using this T, Et, dt as well. Okay, integral as well. And additionally, we have suppose what is a variance, that also you can get. And for this, what is the number of tanks in series? Now this is like a always approaching to a MFR case. So what is the number of tanks in series you are getting? You are getting like 2. Whereas ideal MFR will be having exponential decay. It is closely matching. Otherwise, this can be this is close to a CSTR. Whereas the previous one, this is close to a PFR. Okay, these are all the related information.